want to look at another example of a function, and in this case we just have a verbal description. We are starting out with a verbal description. A woman drives from Aberdeen to Webster in South Dakota, and she's going through Groton on the way, traveling at a constant speed for the whole trip. So that's the situation right here. We have a little map. Apparently there's a highway that goes from Aberdeen through Groton all the way to Webster. And it's 20 miles from Aberdeen to Groton, and it's 40 miles from Groton to Webster. We want to sketch a graph of the woman's distance from Webster as a function of time. So here it looks like our input value is t, time. That's our input. And our output is the distance from Webster. Let's call that d. Let's say d is the distance from Webster. And we can think about d again as a function of time. So at any given time, the woman is either in Aberdeen or in Groton or in Webster or somewhere in between. And we can always compute the distance from Webster as a function of time. Now, they don't give us very much information, so we have to make some decisions as we are drawing this graph. We have t on our input axis, the horizontal axis, and then we have d, our distance, on the vertical axis. They're not telling us what the units are. We can pick. We could say t is in minutes, d is in miles. That would be fine. Well, the distance is given in miles, so there we are. But for time, we could just pick whatever we wanted as units. And so we can think about, okay, we don't have that much information. We just know that the woman starts out. Where does she start out? She starts out in Aberdeen, right here, and she's driving towards Webster, so that is where she is at the end. So at the beginning of this trip, at time t equals 0, she is in Aberdeen, and that is far away from Webster, well, 60 miles. So she is quite a distance away from Webster, and I know how far it is. It's 60 miles. So the distance at t equals 0 is 60. I actually know that. F of 0 is equal to 60. And then at some point, she arrives in Webster. I don't know when that is. I'm just going to pick a point, but she's in Webster, so her distance from Webster is 0. So at the end of the trip, whenever that is, f of that number is 0. And she drives at a constant speed, so I know that I can just connect these 2 points with a line, because she covers the same amount of distance every minute that she's on the road. So if she's going at 60 miles an hour, during the first minute she would go 1 mile, during the second minute she'd go 1 mile. So the entire time she's going at a constant speed. So her distance goes down in a linear way. In part B, we are asked to sketch a graph of the woman's distance from Groton as a function of time. So in this case, t is still time, is still our input, but our output has changed. d now is distance from Webster. And that's our output. So let's see if we can sketch that. The woman still starts in Aberdeen. So at time t equals 0, she is a certain distance away from Groton. And looking back at our map right here, at the beginning, she is 20 miles away from Groton. So I can put that in. I know in this case, f of 0 is equal to 20. And this is a point I can put on my graph right here. So let's say this is 20. And then she drives towards Webster through Groton. So eventually she reaches Groton. Let's say that's here. So this is when she reaches Groton. Now her distance from Groton is 0. And then she drives through Groton towards Webster, so now her distance from Groton increases again. So at first she got closer and closer to Groton at the same speed, and then she just keeps driving, and so she gets further and further away until she arrives in Webster. So that's where our graph ends. And I could put on my graph right here that now she's 40 miles away from Groton. So I know at the end, still I don't know what time that is, but at the end she is 40 miles away from Groton. So we can draw some qualitative graphs that tell us something about the situation, even if we don't know everything about it, even if we can't put specific points on this graph and say much more than what the function values at t equals 0 were. That we could say in both cases.